Welcome back to the Foundation in C# course. We are currently in Module 4, and this lesson, we are going to learn about instantiated classes. Now, this is a big one. Instantiation of classes is one of the foundational principles of object-oriented programming. You're going to do it all the time when you build full applications. So learning about this is really important. But don't worry, it's not that hard. In fact, it's pretty simple once you start to use it a little bit. It can be intimidating though, so just walk with me through it. You'll get through it. It'll be okay. All right? So let's go File, New Project. We're going to start with a console application. We'll say console UI. We'll say that's instantiated class. Names. I should have made it plural. There we go. That would kind of work. I have to actually say like that to get them started. But here's the problem with this. If we do that, then how do I make sure that Tim and Corey stay connected between the two lists? Now, what some people have done in the past, this is going way back, is they would say, okay, well, we're going to put the records that connect with each other on the same number. So, for example, I'll put Tim first on my first name list. So therefore, the first last name is going to be Corey. That way, they stay together. So first names, if you come down here and say first names 1 or 0, actually, that's Tim. And if you say last names at position 0, that's Corey. Well, what happens then if I accidentally delete Tim? Well, Corey's still here, and now things have shifted around and things get messed up, and it causes a mess. So that's not a great option. This works, but it only works for one person. So how do we have multiple people where we have multiple pieces of information about each person? How do we connect all that together and yet have separate things? Now, another option might be, well, we could copy this and we could paste it down here and say first name 2 or 1, last name 1, and address 1. Now there's 2 people. We can do the same thing for the third person. But obviously that doesn't scale. I mean, what if you were a company that had 10,000 users? You don't want that, okay? So that doesn't work. So what's our solution? And that's where class instantiation comes into play. Let's actually wipe out all of this. And let's right-click on console and say add new item class. And we're going to call this the person. I'm going to call it person model. Now, what you name these kind of depends on you, but one of the best practices, or one of the common practices, maybe is a better term for it, is to name a class that stores data primarily or solely, to name it model, meaning that's a model holds information together. It connects different pieces together. So that's what I'm going to do. We call it person model. Now I'll make it public. I will not make it static. Now in here, if I were to say string first name, string last name, and a blueprint. Now, if you're familiar with building houses, when you go to build a house, you first create what's called a blueprint, which is a plan. And it lays out where all the rooms will be, how big they will be, what will be in each room, how it's going to be built, and all the rest. That's a blueprint. However, you can't live in a blueprint. Okay? You can't do it. In the same way, you can't use a class instance without first instantiating it. You can't just use the blueprint itself. That doesn't work. However, when you instantiate it, which is what I did right here, what you're doing is you are building a house from the blueprint. Okay? So we said first is this is the type of house we're going to build. We're going to build a person model house. Where is it going to live? Well, it's going to live right here in this variable name, person. So we're going to put the house at that location. And then how do we actually build the house? Well, this right here equals new person model. What that's doing is it's saying, okay, I'm going to create a new house from this blueprint. Okay? So it's going to create the new blueprint, or from the blueprint, it's going to create a new house, and it's going to put that house in this variable. Now that we have that, I can use all the values in the house, just like when you build a house, you can use all the rooms in the house. So I can say person.firstname equals Tim. Now here's a cool thing. If I come down here and say person model second person equals new person model, so I create a new house, I can say second person dot first name equals Sue. So now if I do a console write line and say person dot first name, and then I do another console write line that says second person dot first name, if we were to run this, and let's do that, it says Tim and then Sue. So I store different information in that same spot. Why? Well, just like if we build two different houses with one set of blueprints, that doesn't mean that the living room is the same living room for both. There's a copy of the living room. Therefore, if I sit in my favorite chair in the living room, I'm not also sitting in my neighbor's chair. My neighbor has his own chair that he can sit in in his living room. The living room looks the same, but I can be in my chair and he can be in his chair and we're not sitting in each other's laps. All right? So that's what's happening here. I built one house. I built a second house off the same blueprint. That is how we can store multiple bits of data together and then have multiple of them. Now, obviously, this is not very efficient to keep creating new person and naming it second person, third person, fourth person. But what we can do is, let's actually just leave this in here. I'll leave this commented out for you so you can see it. What we can do is say list of type person model. Let's call it people equals new list of person model. Now, wait a minute, though. I want to point something out. We've been using list and not really knowing why we do this whole thing right here. But what do you think that is? List is actually a blueprint. And we are instantiating or creating a house from that blueprint and putting it into our variable. In this case, we are creating a list of type person model. So instead of string or int or double, we're saying list of person model. So these houses act like any other type, like string, int, double, bool, and all the rest. You can create your own type, essentially. And so in our case, it's person model is the type, and it holds first name, last name, and email address. So now I could create a new person and add it to my list. So I could say, let's say person model, person equals new person model, person dot first name equals Tim, and let's just add it people dot add person. You can add that person right to the list. Then I could say, and watch this, person equals new person model. What am I doing? In some ways, it feels like I'm bulldozing the house and building a new one, but it's not quite what's happening. Okay? So instead, what's happening is I'm building a new house at a different location, but still calling it person. So person now is a different location. And that may be a little confusing at first, but here's how you think about these variables. The variable holds the street address. Okay? So the variable holds a street address for the house that you built. So what happens when you overwrite that street address with a new street address? Does it mean the old street address goes away? No. That house is already built. It's already done. It's built. And so it stays there. It's just that now this variable holds a new street address. In fact, the new street address is for a brand new house that was just built. So then I could say person dot first name equals Sue. And then I can say people dot add person. Now I add the same person twice? No, because I did this new street address into that variable. So now what I could do is I can do a for each person model. I can say P for now, in people. So my list is a list of person model. So for each one is a person model. So now I can say console write line P dot first name. Now, how am I passing these values around? These whole houses. Am I making copies? No. I'm just copying the street address. So now people has two different street addresses. And at each one, we're going to open the door and look in the living room and find that value. So if I run this, it says Tim and Sue. So now I have as many as I want, but I can keep overwriting the street address and then adding that new one to the list. Let's put some better spacing in here so you can see it a little better. Now, if you're new to instantiation, you might be a little bit struggling right now. You might say, oh, well, I'm just not quite getting it. And that's okay. That's perfectly normal. It takes a little bit of practice. Once you get a little bit of practice under your belt, I think you'll be fine. So I'm going to do one more thing, one more adjustment, and then we're going to start using class instances. Okay, so what I'm going to do is I'm going to comment all of this out. That way you have it in the source code, and that's, of course, downloaded below the video. That's what happens with all of our source code, is I put it below the video for every lesson. But I'm going to come over here to the person model and make one change. Let's comment all of these out so you can have them for later. But this is not really the way you're supposed to use data in class instances. These variables don't really work well with class instances. And there are some reasons for it that you're not going to get into quite yet. But when it comes to data binding and reflection and a couple of other things, they don't work as well as what we're going to be doing today. I'm going to show you an introduction to properties. Now, I have a whole lesson on properties coming up, and so we're not going to cover all of what properties can do because that would make a lesson too long. But we're going to use the simplest and most common property today, and that's called the auto property. These are easy to do, and they're awesome. So, if you type prop, P-R-O-P, P-R-O-P, there we go, and you tab twice, it creates our auto property for us. And then allows us, using the tab key, to move between different sections. So I'm going to recreate what we have up here. Let's say string, then tab, and say first name, and hit enter. When I hit enter, it's going to go to the end of the line. I can hit enter again, and now I'm down below. So a little faster, prop, tab, tab, string, tab, last name, enter. You can do this really quick. Okay, so now I've created 3 properties that mimic our fields or our variables we had up here. So there's a couple of subtle differences with our properties versus our fields. So the first one is that instead of just public string in the name, we have this at the end of it. Get and a set inside curly braces. For auto properties, you just leave us alone. That just indicates that it's an auto property. Second, and we'll see more about why we have get and set here. Essentially, this one returns a value. This one sets the value when we use this property. And in the properties video, we'll talk about expanding these and actually creating whole methods, essentially, out of them. But again, the simplest and most common thing is auto properties. The other thing is the naming convention is a little different. Notice first name, we're using camel case, meaning the first word, the entire first word, is lowercase. And after that, every word gets a capital first letter. Well, here we're using Pascal case, which means that every word, the first letter is capitalized. This is a industry standard convention. So I would highly recommend that you do not deviate from it. There's a couple reasons for it. The most important reason is because then your code doesn't mesh well with others. But the other reason why is because when you use Pascal naming convention, in your code, when you have a private variable or a variable that's just for your class or method, when you're using camel case, because C# is case sensitive, you're not going to step on toes. So if we had a private variable called first name, notice it doesn't conflict because that's a camel case, that's Pascal case. So no problems. So over here in my code, if I called the class, instead of person model, if I call it person, I could say person, lowercase person, and people, and it wouldn't have a problem. Even though I'm saying person, and people, because of the fact that they're different casing, it would be different, and that's valid. The other thing is it allows us to see that, you know what? That comes from somewhere externally because it's an internal variable would be camel case. So just follow the convention. I can't stress that enough. If you go into a work environment, you will almost always see this convention. And so not following it now might set up bad habits that will make it more difficult for you later when you try to integrate into a workforce. If you're your own boss or you're the boss of a shop and you say, you know what? Nope, we're going to do something different. It's going to make it harder when you try to integrate third-party code into your application, including Microsoft's code, because Microsoft's code all follows this convention. Okay, enough about the lectures about the different casing. Let's start using this instance idea. All right. So what we're going to do is I am going to create a small loop. And in that loop, I'm going to capture people's first names. So let's create first a list of person model called people. And I'm also going to create a string first name. And then I'm going to do a do loop and say, wow, first name is, let's say first name to lower is not equal to exit. Okay? So if a person fills in exit as their first name, which wouldn't be a normal first name, then it's going to exit the do loop. So console.write what is your first name, or type exit to quit, to stop. How about that? There we go. And we're going to say first name equals console.readline. We're going to say if first name to lower is not equal to exit, and yes, I'm repeating my code here, but that's necessary. I'm going to say people dot add first name, and that won't work. I got to create an instance first. Well, person model person equals new person model. Person dot first name equals first name. People dot add person. Okay. Now remember, whenever you create a variable, it lives in the context of the curly braces it was created. In this case, inside these curly braces. As soon as you come down here to this bottom curly brace, that person variable gets blown away, gets erased. However, that is just holding the address to the new house we built. So, since I already used that address and add it to my grab the first name, just so we have something. Okay, so we're going to loop through. Now, what this is going to do is it's going to allow us to put as many people in this list as we want to. And we could have multiple names associated. Now, in this case, we don't, unless, of course, we decide to add a last name or an email address. But if I run this, type of first name, Tim, Sue, Bob, Joe, Mary, and exit. Tim, Sue, Bob, Joe, Mary. Okay, so it actually created 5 different instances and put a value into each. So for example, we could expand this a bit and maybe ask for a last name as well. And we're not going to care about checking the last name, so we'll just take that off and say last name. We've got to declare it. And again, I don't need to declare it out here because I'm not checking it outside the curly braces. So now I can say person.last name equals last name. And then for our right line down here, let's add these 2 together. Like so. And now we should see our first and last name. So Tim, Corey, Sue, Storm, Bob, Huggins, and exit, enter. All right? Tim, Corey, Sue Storm, and Bob Huggins. So it's captured that data, and it knows to put Corey with Tim because it's in the same house. Just has 2 different rooms. And same as Sue Storm and Bob Huggins. So that is the power of instantiation. We're going to use this a lot going forward. Now, we could put methods in here as well. And there's a case for that sometimes. The idea of putting methods and data together, some people like to do it a lot. I tend to separate my classes that have methods from my classes that have data because they're doing 2 separate things at that point, usually. Now, there are cases to mix the 2 or blend the 2 together. But in general, I kind of separate. Now, class instances are almost exclusively where we store data. Remember that I said there's very few cases where a static class should have data. Well, this is where we put our data instead. An instantiated class, because then we can have it live however long you want it to, for a short period of time or a long period of time, and it holds multiple pieces of data together so they don't get sorted in different spots. They don't get mismatched, all right? It keeps them all together and connected. Now, the other thing to note is that when we pass these instances around, so let's create I had to create a new static class. New class. We're going to call this process person. Make it a public static class. And we're going to say that public static void greet person. We're going to pass in a person model called person. And one of the things we're going to do is in the person model, we're going to add a property, a Boolean called has been greeted. All right, so in here, we're going to say console write line. We'll actually just grab this code since it's convenient. I'm going to copy it and paste it in here. And I'm going to say hello beforehand. Hello. Now notice P is causing a problem. So let's, person.first name, person.last name. And then I'm going to say person.has been greeted equals true. Now, notice what I'm not doing. I'm not returning any data. So is it a useless thing to change a value on person? No, it's not. Because remember what we are doing here. When we pass in a person model into this parameter, we're not making a copy. If I asked you for where you lived and you sent me your address, you're not sending me a copy of your entire house. You're just sending me the location of your house. So if you have the location of your house and I have the location of your house, then if you change something about your house, maybe you paint the house or you add put an addition on, we still both know about that change because we both have access to that same location via the address. So if you make a change over here to this particular address, then everyone who has access to that address sees the same change. Let's see this in practice. Over here, we're going to loop through every person. But instead of doing this, we're going to say process person dot greet person and pass in each person. Now I'm going to put a breakpoint right here and a breakpoint right here. And let's just observe what happens. So I'm going to ask for, I'm going to say Tim, Corey, Sue, Storm, and Bilbo Baggins. All right, now let's pause. Remember I said sometimes the debugger, when it pauses, it doesn't hide the window? This is one of those cases. We're paused right here. So let's look at this people list. Notice it says it has 3 in it. And if we expand it, we can see that each one is a person model. If we expand the first one, there's no email address. First name is Tim, last name is Corey, has been greeted. Obvious, Tim. But the reality is you're going to forget this at some point and you're going to assume you're making a copy. I've done this where I've actually said, okay, I need to return a person model, and then I make the change and return that same person model. You don't need to do that. Okay? If you make a change anywhere to that same instance, everyone knows about it. So going forward, this is what we'll be using for all of our data we get from different places, or all of our data we need to store together. different pieces of information. It's also what we'll be using to have a lot of our methods as well. In fact, and this is why I don't teach Windows forms first. Windows forms are just class instances. They have properties and they have methods. They also have events, but properties and methods attached to them that you instantiate. So if you've ever had a problem with Windows forms where something breaks, you don't know how to fix it, that's probably because you didn't understand how the form was built. It's not just this magical thing that you drag and drop items onto. Everything you drag and drop onto that form is actually a class. And so you drag something on a button onto your form, you're actually creating a new instance of that button. Every one of them. So you have 5 buttons, you have 5 instances of the button class. A form itself, every form is an instance of the form that you designed. So you can actually have 2 or 3 different instances open at the same time. So that's just to say that that's why I teach in this order, because I want you to learn how these class instances work first and get comfortable with them so that it's not magical later, because whenever it's magical, magic can break, and when it breaks, then you're up a creek, and I don't want that. Okay, so class instances, we'll be using it a lot, especially for data, but also for our methods as well. Okay, so let's look at our tip for today, and that is, in general, instantiated classes store data. Now, static classes are used for stateless processing. That's the general rule. Now, there are exceptions to both rules, but in general, this is the rule. Instantiated classes store data, and static classes are for stateless processing. The reality is we don't use very many static classes in applications. More likely, we use instantiated classes. Okay? So, your homework for today is to create a console application that has a person class and an address class. Now, why would I just have you create 2 classes? I want you to think about what you would put in each class. What goes there? For example, does a person have a home address? And if so, what variable type is that? All right, so I want you to think about that. Build a console application that has a person class and an address class. All right, once you're done with that, then come on back for the next lesson.